APIs are how different software systems communicate with each other. Let's see how Python can interact with APIs to fetch data from the web. The requests library is a powerful tool for interacting with web APIs. In this example, we're fetching data from GitHub's API and printing it out as JSON. APIs are a huge part of modern software development, whether you're pulling data from a web service, integrating with third-party tools, or even building your own backend services. If you're ready to level up your Python skills, stick around because this video is going to be packed with valuable insights and hands-on examples. Let's dive in. Before we start, here's a quick challenge for you. Pick a public API of your choice and use Python to fetch and display some data. What did you choose? Share your code and findings in the comments below. All right, let's kick things off with a brief introduction to APIs. API stands for Application Programming Interface, which is essentially a set of rules and tools that allow different software applications to communicate with each other. When we talk about APIs in Python, we're usually referring to web APIs, which let us interact with services over the internet. For example, think of when you use a weather app on your phone. That app doesn't actually generate the weather data itself. It fetches it from an external service, probably via an API. Python makes it super easy to interact with these web APIs, and today, I'm going to show you exactly how to do that. Before we start making any API requests, we need a way to send HTTP requests from Python. The most popular library for this is called requests. It's simple to use and handles all the heavy lifting for you. To install requests, you just need to run the following command in your terminal or command prompt. Once that's installed, we're good to go. Let's start by importing it into our Python script. One of the most common API requests you'll make is a GET request, which is used to retrieve data from a server. Let's walk through an example using a public API. We'll use the JSON placeholder API, which is great for testing and prototyping. Here's how you make a simple GET request to fetch some data about users. This line sends a GET request to the specified URL. The response from the server is stored in the response variable. Now, you might be wondering, what exactly is inside this response? Let's find out. The response object we get back from requests is quite powerful. It contains all the information about our HTTP request, including the status code, headers, and of course, the content itself. A status code of 200 means everything went smoothly. Now, let's take a look at the actual data returned by the API. Since this API returns data in JSON format, we can use the JSON method to parse it. And there you go. We've got a Python dictionary containing user information. Each user is represented as a dictionary inside a list. Now, you can easily loop through this data and manipulate it however you need. Of course, not all requests go smoothly. Sometimes the server might be down, or you might hit an endpoint that doesn't exist. That's why it's important to handle errors and exceptions gracefully. Here's a quick way to check if your request was successful and handle any potential errors. By using raise for status, we can ensure that our script doesn't silently fail if something goes wrong. This makes debugging a lot easier. Here our request is successful, so there is no error. If we enter the wrong URL, then it will throw an error. Now that we've covered GET requests, let's move on to POST requests. While GET requests are used to retrieve data, POST requests are used to send data to a server. This could be anything from submitting a form, uploading a file, or creating a new record in a database. Let's try posting some data to the JSON placeholder API. We'll send a new POST object to the server. Here, we're sending a dictionary as JSON to the server. The server will return a response containing the newly created resource. Let's take a look at the response. As you can see, the server responds with the data we just posted, along with a unique ID for the new post. This is a common pattern you'll see when working with APIs. Not all APIs are open and free to use. Many require authentication, which usually means you need to send some sort of credential with your requests, like an API key or a token. Let's simulate this with a header. Imagine we're working with an API that requires an API key to access. Here's how you'd add that to your request. Adding headers is as simple as passing a dictionary to the headers parameter. This dictionary can contain any number of headers you need, whether it's for authentication, content type, or anything else. Sometimes you need to filter the data you're requesting. And this is where query parameters come in. Query parameters are added to the end of a URL to specify things like search terms, pagination, or filters. Here's how you'd add query parameters to a GET request. In this case, we're requesting all posts made by the user with ID 1. The params dictionary gets appended to the URL as query parameters. APIs can return data in different formats, the most common being JSON, but sometimes you'll encounter XML or plain text. The request library can handle these formats as well. Let's quickly look at an example with XML. If we print the content, you'll see it's raw XML data. To work with this data in Python, you'd likely use an XML parser or a library like Beautiful Soup for more complex structures. But the request library gives you the raw data to start with. When dealing with large data sets, APIs often use pagination to split the data into chunks. Understanding how to handle paginated responses is crucial. Here's a quick example using a paginated API. This loop will continue fetching pages of data until it fetches the desired number of pages, or there are no more pages left. This pattern is very common in APIs that handle large data sets. Before we wrap up, let's go over some best practices when working with APIs in Python. Rate limiting. Be aware of rate limits imposed by the API. Some APIs restrict the number of requests you can make in a given time period. Implementing a delay between requests or handling rate limit errors is crucial. Caching. For APIs that provide static or rarely changing data, consider implementing caching to avoid unnecessary requests. Error handling. Always handle errors gracefully. This includes checking for status codes, handling network issues, and managing timeouts. Documentation. Read the API's documentation thoroughly. Each API has its quirks, and understanding these can save you a lot of time and frustration. Security. Never hard-code API keys or sensitive data directly in your scripts. Use environment variables or configuration files that are excluded from version control. And with that, we've covered a ton of ground. We've looked at how to make GET and POST requests, handle errors, work with authentication, and much more. Working with APIs is a powerful skill, and with Python, it's incredibly accessible. I hope this video has made you feel more confident in your ability to interact with APIs in Python. Thanks so much for watching. If you found this video helpful, don't forget to give it a thumbs up, share it with your friends, and subscribe to the channel for more in-depth programming tutorials. Leave a comment below if you have any questions or if there's a specific topic you'd like me to cover next. Until next time, happy coding